Quadratic functions in factored form. Here it is on the right, the last equation that we looked at with our third quadratic functions in factored form graph. Now you can see some distinct things about vertex form. Number one, it has a negative there in front, so we knew it was upside down. It also was easy to see where the vertex was because we did the opposite of the x, which was positive 7 in this case, and then down 1. So positive 7, down 1, and I can click on that, and it says that it's at positive 7, negative 1. And that is very, very helpful when finding the vertex. However, it's not helpful for finding what are called the x-intercepts. So if I replace this graph now, and I have, let's bring that down a little bit. X squared minus 2. I could see that I have my 3 points here that are lit up. The bottom is 0, negative 2. But then what about these other ones where it crosses the x-axis? Well, it looks like these are at negative 1.414 and symmetrically at 1.4140. This is a little ugly because they're not integers, they're decimals. But these are what's known as our x-intercepts. And when graphing any parabola, it's important to try and have 3 points that we can graph. Usually the vertex and then the intercepts and connect them. Today, we're going to learn a form that makes finding those intercepts really easy. Uh-oh, it says preview. I wonder if I've been doing this for days and days and days. So check it out. We're now going to type in this new graph. F of x or y, we'll use y since it says y, equals negative, so it's going to be upside down still. And then check it out. X plus 11, x plus 3. Okay, because it's 11, I'm going to zoom out a little bit here. All right, so here's our graph. There's our vertex point. That is not easy to see from this information. We'd have to do some calculations separately for that. But what we can see, remember what I've said the whole time. Anytime we have numbers in parentheses, remember this meant not go right 11, this meant go left 11 for negative 11. Similarly, this did not mean go right 3, positive 3, it meant go left 3. And so when you click on these points, you see that we have negative 11 and negative 3 matching the opposites up here, negative 11 and negative 3. Notice it doesn't have to do with this negative. This negative just tells you it's going to be upside down and look like that lowercase n for negative. Whether this was negative or not, you'd still have negative 11 and negative 3 as your intercepts. The only difference is it would be a U shape instead of an N if we didn't have that negative. So we look and we find the one, for me it's the first one, where our x-intercepts are sure. Look at where it's crossing down here at this arrow. Negative 11 and negative 3. This one's not a n. This one's an n, but crossing at negative 11 and positive 3. This is not an n. This is negative 3 and positive 11. This is not an n. This is at 3 and 11, both positive. This is not an n. Wow, we have a lot of choices here. This is negative 11 and was not an n either. Not an n, not an n. What? We have so many choices. Okay. Once you get your right choice, just click it. That is unbelievable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 choices? Wow. Okay. Good thing you got me here. This one's going to be upside down again, and now we're going to go with the opposites. So this is going to be positive 1 and positive 9. And for the sake of explaining, let me show you. Bam, it's over on the right now at positive 1 and positive 9. And so once again, lucky for us, it's the first one. Because I don't want to go through all 12 options each time. Positive 1, positive 9, match it up. 2 for 2. Okay. Now I've got a 2 in front. Remember what that did? It made it vertically stretch. See how much taller that got? It didn't even fit in my graph. There it is. At positive 10 and positive 6 means that we have to go backwards. And this will be touching at negative 10 and negative 6. So it's not the first one again. Dang. Because this one's way over at positive 15 and positive 18 or 19. Not even close. -10 and -6. Okay, the only thing we have to check is there any one that's more stretched than that? Negative, no, that's not even close, not even close. Okay, oh good, there's not that many choices. Instead of 12 choices, there's only 1, 2, 3, 4, 5, 6. Oh, we literally cut the choices in half from 12 to 6. We still found the one. There's only one that was in the right spot where we had -10 and -6. And it was upside down. This one's not going to be upside down because we get rid of the negative. But it is going to be at -13 and -7. -13 and -7. See? 13 and 7. But it is also stretched. So let's see. Is there any one that's more stretched than this? This is the right spot. Let's make sure. -13 and -7. Yes. This one. See, this point goes all the way down here to -10, -18, where the top one, that vertex point, is at -10, but only goes down to -9. So if you clicked the first one, I can't blame you. It had the right x-intercepts, and it was the first one, the first two problems. So understandably, you're like, oh, sweet, the first one. I don't have to go through and check the rest of them. That's why you missed it. We have to choose the one that has the right vertex point and that has the right stretch. Desmos makes it so easy to just come over here and click on what is that point down here. That is a big advantage it has compared to our graphing calculator. You'd have to do more calculations and different button combinations to get that. Okay, hey, we know what this is. Determine whether we have a max or minimum. Just like before, we simply ask ourselves, do we have a negative in front? If so, we can ignore the rest, even though it's in factored form. It's got a maximum. It's an upside down in for negative. Similarly, if it doesn't, it's a regular U-shaped parabola, just like we have over here, with a minimum. Yay. All right, moving on in 3, 2, 1, go. It's so weird to do that with pausing videos, but very helpful. Okay, now we're going to simply enter the zeros of the function. So I can type this out over here again. And then I could see, oh, my zeros are at 5, 0, and 8, 0. But this is another one of those where it's even easier to just look at my equation and ask myself, okay, the zeros of the function, especially from the x perspective, mean what values can I plug into my x's and get 0? So in other words, if I ignore this negative and I ignore this x minus 5, what number minus 8 is 0? Well, positive 8. It says separate your answers with a comma, so I'm doing that now. And then what number minus 5 is 0? Oh, 5. The same thing for the next one. Now we have positive 9 and positive 7. So then the opposites will be negative 9 and negative 7. Not too bad at all. And then we just have 2 more. Fill in the blank with the exact values of the zeros of the quadratic function. If more than one value exists, use the spacebar. So instead of using a comma this time, we're going to use the spacebar. Let's start easy with this one. X minus 8, we know that it's positive 8. Then we need to hit a spacebar instead of a comma. And now we have this question. I'm going to write out this one. Negative x. All right, so negative x equals 0. If I literally write this equation out, I'm asking myself, what value can I plug in for x that when I make it negative, I get 0? This one is an interesting problem I ask every year, and every year it stumps people because they overthink it. They think, all right, gosh, negative, I don't know, negative 2? No, that's just negative 2. Negative 10? No, that's just negative 10. What number can I make negative and get 0? if you find yourself going, oh, 0, 0, 0, oh, hey, you've mumbled it correctly. It's 0. Negative 0, positive 0, it's just 0. So put whatever number you have for the opposite of your parenthesis again, space, and then 0. If you got that quick at home or at school, if you're watching this at school, high five yourself. Great job. You did not fall for the trick question. If you did, don't worry. Everyone does. Same thing for this one. We've got the opposite of positive 3. That's negative 3. Space, and then we have another x or negative x. Anytime you see that, it's just automatically 0. That's a 9. Whoa! Keyboard went crazy on me for a second. Negative 3 space 0. Okay, we've gotten through 3 different assignments with vertex form, and now we are officially done once it shows us that 100 with da-da-da-da-da-da factored form. Oh, and I did end up starting this correctly, so it only took 9 minutes, 37 seconds. Good. Whew. It's not like those 26 days from a few assignments ago. All right. Cool, cool, cool. We have just a few more assignments left in this quadratic functions unit, and I believe, if I'm right, in this grading period as well. So there you go. First quarter, almost in the books. That's exciting times. Much love and best wishes from your teacher, Dylan. This has been Class Away from Class. Have a great day.